Hello, Professor Tran. How are you?
Hey, Hutton. Good. How are you?
Pretty good. Just going through all my classes so far. You're my last new class, I guess. So
I see.
last syllabus to go through.
Yeah. Last syllabus. Yeah, this one's in a late slot on Tuesday. So yeah, I assume probably a lot of people have had classes up to this point.
Yeah. How's your winter break?
A lot of stuff happened. Some not so good stuff, but it's
Sorry to
okay.
hear
Got through it, and excited to start the semester. How about you?
Sounds good. Nothing much. Worked a bit on the Titan rocket project. Got a haircut. You probably remember me with long hair every now and then, but
I did. Yes.
yeah, I had to trim it up. Got to start going to internship interviews now and stuff. So
You got to go clean for those.
yeah, but other than that, just kind of hung out, try to relax as much as I can before the new year started.
That's good. That's good.
But I'm excited for this class because it just seems really interesting. That's really the only reason I signed up for it.
Yeah, last year it went pretty well. It is pretty unique. So yeah, I'm hoping you guys enjoy it this semester.
I'm looking forward to it.
Hey, Prem, how are you? That's good. That's good. How was your break?
Hi, Professor. My break was great. I was in Florida for about 2 weeks.
Nice, nice. Oh, sounds nice. Yeah, it was nice to get away during the break. What did you do in Florida?
My brother lives there, so I was visiting my brother. He took me to a few places, spent my New Year there in Sarasota. Went to see like a pineapple drop in Sarasota.
Oh, okay. Nice. That sounds fun.
It was fun. It was nice.
That's
And then I
good. That's
went to
good.
Orlando for a couple of days. Saw
Nice,
the
nice.
downtown life of Orlando. It was nice.
That's nice, nice. That's good. Was it warm over there while you were there?
Yeah, it was warm when I was there, but uh, when I flew back, then it got colder there. It
I
was
see, I
like
see.
-1 Celsius there when
Oh, wow.
I came back.
Oh, wow. Yeah, it was pretty cool here actually over the break in California. Yeah, it was like, I mean, cool for California. I mean, not
Cool for California.
yeah,
Yeah.
yeah. Compared to other parts of the world, still very,
Mhm.
very nice. But for Californians, it was quite cold.
Absolutely. Even I come from a warmer region, so this is already a lot colder for me.
I see, I see.
Professor, I had something to ask, by the way.
Sure. Mm-hmm.
So I'm taking 541 this semester. You must have seen me in the class yesterday. So
Yeah. Mm-hmm.
so is it a good idea to take 442 and 541 the same semester?
Yeah, sure. I mean, there's very little overlap between them, and
Mhm.
so I mean, you're going to get I mean, almost basically no overlap, and so I mean, they're both very, very different educational experiences, and so yeah, I'd say it's fine as long as it works with your schedule.
Yeah, it does.
Mhm.
All right, thank you.
Oh shoot! Thanks for catching that. Oh, it does. I changed the one on the top right here, but then I didn't change the one down here. Thanks for doing that. Thanks for catching that. Let me go ahead and do this. Let me send an announcement too, because probably some people might be confused by that. Have I heard of pericarditis? It sounds familiar. I mean, I can piece out some of the words in there because anytime you have cardi something, that means something with the heart. Um, I'm not sure exactly what it refers to though. Hang on, let me change this real quick. Oh shoot. Let me look it up real quick. Let me see if I can tease it out. Let's see. I see. Okay. Oh man. Oh, that sounds painful. Um, what did the doctors recommend that you do with it? or I guess, we can talk offline. You don't have to share your personal medical information on the public chat. But I see. Yeah, I think any kind of anti-inflammatory medicine would probably work. Yeah, ibuprofen I think is good. But yeah, hopefully you feel better. I mean, that sounds awful. Yeah, morphine will do the trick. Morphine will, well, I won't say it fixes everything, but it'll make you feel like everything is fixed. I don't know about that. My class doesn't cure anything. All right, it's 4 o'clock, so let's go ahead and get started. All right, so welcome everybody. And so this is, I'm sure everyone's had class at this point, but I just want to say welcome to the spring semester and welcome to this course. So this course is EGME 442, Computational Cardiovascular Engineering, and so this is a technical elective. This class is kind of my baby a little bit, and so it's a lot of it's based on a lot of the research that I do. And a lot of the the previous work that I've done. So this would be the second time I've taught it, and so the first time I taught it, I think it went pretty well. So I'm hoping this one will go well as well. Okay. So my name is Professor Justin Tran, and the plan for today is I just want to introduce what the course is to you guys. Because it's a technical elective course, and it is quite different from a lot of the courses that you've probably taken up to this point. And so I do want to give a brief introduction to that. And then after that, my only plan is to just go over the syllabus. Okay. So I don't have any content planned for today. So if we can get through everything quickly, then we might end 5, 10, 15 minutes early. Okay. All right. So before we begin, are there any questions I can answer? Okay, all right, so let's go ahead and get started. Okay, so a little bit about myself. So my name is Professor Justin Tran. In terms of what you can call me, I'm very open to to anything. So you can call me whatever feels comfortable to you. So a lot of people call me Dr. Tran. A lot of people call me Professor. Some people just call me by my first name, Justin, or whatever you want. To me, a name is just a name. It's not it's not anything more than that. So as long as it's comfortable for you, it's comfortable for me. Okay. And so my office is in the computer science building, and so it's in CS 526. And so it's actually just upstairs, two floors upstairs for where our usual lecture room is. So obviously, we're not there right now because the first 2 weeks of the semester is virtual. But once we come back, then I'll be in my office. You can find me in my office for for most of the day. I probably won't come in early mornings just because I'm I teach a lot of evening classes, but most of the afternoons you can find me in my office. Okay? My email address is justran@fullerton.edu, and so I always tell people that it's easy to remember. Just think of maybe you just ran a mile or you just ran a 5K. Whenever you do those things, just think that that's Dr. Tran's email. Okay. So I grew up around here. So I grew up in Cyprus, which is, if you're not sure where that is, that's about 10 miles west of campus. And so I'm very familiar with this area. I'm very familiar with this school. Actually, a lot of my good friends from high school actually came to Cal State Fullerton. And so, it's a great, it's a great privilege to be here and to be able to teach what I feel is other people that are in the community that I grew up in. So, I'm very happy to be here. Right? A little bit about my educational background. I got my bachelor's from UCLA. I got my master's from UCSD, and my PhD was from Stanford. So all of those were in the mechanical engineering departments, and so I'm very familiar with how these kinds of departments work. Okay, and my research interests, as you'll get a very up close and personal look in this class, have to do with engineering applications for heart and blood disease. And so I won't say anything more on that because that's kind of what the whole class is about. And so, we'll spend the rest of the day talking about that. And just naturally, just as an educator in in the sciences, I'm also interested in more effective ways that we can teach science better to people. Okay. All right, learning objectives. And so if you've had me before, and I know that there's quite a few of you that have been in my previous courses, so you're probably familiar with these. But if not, you'll get to know these very well. And so I love these learning objectives because they're basically my way of organizing the content in the course, right? And so every day, what you'll see is that I'll have posted a list of learning objectives. And there will be about, usually between 2 and 4 of them. And what those will describe is, not only are they going to describe the topics that we're going to cover for that day, but they're also a description of what skills and what knowledge I want you to obtain from the lecture, after its conclusion. Okay. And if you read each of them, I'm very careful about how I write these. And so you'll notice that every single one of these starts with a verb. Okay. And that's on purpose. Okay. And so I love the verbs because they describe a certain kind of action or a certain kind of skill that you can do to demonstrate your mastery of the material. Okay. And so what I always tell people, what I always recommend is that at the beginning of every lecture, when you're preparing your notes for the day, write down the learning objectives that I have for you for that day, right? And then after class, after you're done writing the notes and paying excellent attention to the lectures, you can go back to your learning objectives and use those to assess how well that you understood the lecture for that day. Okay. And so, for example, after today's lecture, you should be able to describe the role and importance of the cardiovascular system. Okay. You're not gonna be able to do that yet, or maybe you can, but because we haven't gone over it yet. But after the lecture today, go back to this learning objective and say, after I saw the lecture on this Tuesday, am I able to describe the role and importance of the cardiovascular system, in like 2 or 3, 4 sentences? Okay. And if you're able to do that, then that's great. That means that you got that part of the lecture, you've mastered that part. But if you're not able to do this, then maybe that's a good idea to go back to the lecture notes, maybe watch the recording again to make sure that you can pick up that part of the lecture. Okay. And so these learning objectives, I love them because I think not only do they do a great job of kind of organizing what I want to get to you guys and what I want you to get out of, but it's also kind of a way for you to kind of self-assess and to study for yourself to make sure that you're getting everything out of the lectures that you can. Okay. And so you'll be seeing these a lot throughout this semester. So and I don't do them just randomly. I take a lot of time and thought in writing these. So definitely use them to your advantage to help you get the most out of this class. Okay. All right, and so with that all out of the way, let's describe, let's just talk about, what the hell is this class, right? And so, I've chosen, 3 very long words for this course. Okay, so we have computational, cardiovascular, and engineering. Okay, and so I think the first, and this is kind of the reaction that a lot of my colleagues had. It kind of seems like hey Justin, you're kind of just putting 3 long words together that might seem kind of fancy, right? And and I don't blame you for that, right? Because these 3 words usually don't have too much to do with each other. Okay. But if I could sum up this class in a single sentence, how I would describe it is that this class is about how to leverage our knowledge of fluid mechanics and computer programming to better learn about and study the cardiovascular system. Okay. And so to that end, I want to break down kind of each word that I have here in the course title to kind of describe to you why I chose those words. Okay. So let's start with computational. Okay. All right, so whenever you see computational in front of a, in any context or in an engineering context, what they mean by that is, we're going to use some kind of engineering software on a computer to perform computation and analysis. Okay. And so, I know probably a lot of you are either graduate students or you're seniors, or you're kind of more advanced in your degree, and so you've probably taken classes that have used softwares like SolidWorks or ANSYS. Okay. And so whenever you see computational or computer aided or anything with compute, it means we're going to leverage some kind of software like that. Okay. And this class is no different. And so this class, we're going to use, a couple softwares to help us in our analysis, right? So one of those being MATLAB, and another one called Syllabus, which is the CFD software that we'll use. And I'll go over that later. Okay. All right, so the next part of the title is cardiovascular. Okay, so this is the kind of the medical portion of this course. Okay, And so the cardiovascular system, you can think of this as our engineering system of interest, okay? And so whenever you perform engineering work, you always have some kind of system of interest, right? And so if you're a structural engineer, you're going to be working on things like buildings or bridges or things like that, right? If you're a thermal engineer, you're going to be working on, maybe heat sinks, maybe fins, things like that. Okay, so for this class, our system of interest is actually the human body, okay? And in particular, the cardiovascular system and the human body, right? And so the cardiovascular system consists of your heart, your blood vessels, and the blood itself, right? And so it's a unique kind of system, because normally, we don't really work with living systems a lot as mechanical engineers, but I think that's what makes this class very unique. Okay? And of course, the last word in the title here is engineering, right? And so engineering is basically the work that engineers are expected to do. Okay. And so you can describe engineering work in a lot of different ways, but the way that I like to think of engineering work is, we as engineers, we solve real world problems, right? And so we're problem solvers. And so, there's lots of different problems in the world, and, engineering or engineers, what we do is we use science and math to perform analysis, design, and optimization to solve these problems, okay? And the cardiovascular system is no different than any other system out there, where, the cardiovascular system has a host of its problems, things like cardiovascular disease or medical device design, right? And so, there's a lot of work, a lot of potential good work that engineers can do, for these systems, okay? And so that's kind of the rationale of why I kind of chose the name for this course, and a little bit of a preview of what you're going to be expecting to learn. Okay. Any questions on any of this so far? Okay. Okay, and so let's go over in detail a little bit more about each of the components of this class, right? So let's start with some of the biology, right? And so, so I think, the number one concern that a lot of people have in this course is that, it's been a while since probably a lot of you have taken any kind of biology course. So for some of you, it might have been all the way back in high school, right? And so, and so I'm aware of that, and I was the same way too. And so when I was first learning these subjects, I hadn't taken a biology course in years. And so, all the biological concepts, we're going to, motivate them from scratch. And so, I assume that, people are coming in with very little biological knowledge. Okay. And so we're going to start kind of at the basics of the basics, and then kind of talk about them as they relate to engineering. Okay. All right, so first let's talk about the cardiovascular system in general. So just like I mentioned on the previous slide, the cardiovascular system, your cardiovascular system consists of your heart, all your blood vessels, and all the blood inside your body. Okay, and so here's kind of a nice computer, computer rendering of that, right? And let's talk about what the primary role of the cardiovascular system is. Okay, and so the primary role of the cardiovascular system is actually the way for your body to transport stuff in your body. Okay, and so that's why I have transporting here underlined, right? Because your body, it just like our the supply chain here in the United States, we need to move stuff from one point to another one, right? And the way that your body moves stuff from one point to another, most of the time, is going to be through the cardiovascular system. Okay, and so some examples of objects that your body moves around are things like oxygen. Okay, and so the oxygen needs to come from your lungs, and it needs to go to every part of your body. Okay, and so the way it does that is through the cardiovascular system. Nutrients are transported through the cardiovascular system, enzymes, hormones, and actually heat as well, right? And so a lot of people don't think of the cardiovascular system as as a heat exchanger, but that's basically what it is. Okay, and so it's really the cardiovascular system is this very vastly interconnected, almost like a network of pipes inside your body that transport stuff from one port to the other one, right? And I think everyone knows that your cardiovascular system is extremely important, and so you need to properly maintain it through diet and exercise, right? And so a happy heart leads to a happy life, right? And so I think everyone's seen those Cheerios commercials going up. And I think one thing that people don't realize is how vast the cardiovascular system is in every human. Okay, you have so many blood vessels that that you just aren't even aware of. That if you took the average person and you kind of ripped out all their blood vessels and kind of linked them kind of end to end, it would span about 60,000 miles or 100,000 kilometers. And so every single person basically has 60,000 miles of blood vessels inside them, which is, to me, I think that's really crazy to think about. Oh, and if you have any questions on anything, just kind of stop me at any time. This today is going to be pretty informal. All right, so let's talk about cardiovascular disease, right? And so I think a lot of people they become familiar with the cardiovascular system because they start to develop disease, either themselves or most often a family member. Okay. And so cardiovascular disease is a very, very broad term. And so when people talk about disease in the cardiovascular system, it basically refers to any kind of abnormality in the system that impedes healthy function. Okay. And so some examples of cardiovascular disease that we'll talk about in this class are things like high blood pressure, right? Things like aneurysms, heart attack, and stroke. All of these kind of fall under that category, right? And it's a huge concern, right? And so cardiovascular disease is still the leading cause of death worldwide. And so if you consider all the deaths that happen every year and you count them up, about 17 million of these occur each year due to cardiovascular disease. And in the U.S. alone, 600,000 of these are due to cardiovascular disease. Okay? And it's not only the cost of life. And so treating cardiovascular disease is also extremely expensive as well. And so I think one of the more recent estimates that treating cardiovascular disease in terms of the healthcare and the lost productivity, right? And so a lot of times when people have a heart attack, then they can't go into work. That costs the U.S. about $500 million each year in excess of that, right? And so that's a huge burden on our economic system. Okay? And so I think everyone kind of agrees that a better understanding of cardiovascular disease mechanisms and treatments is always going to be in need, because the more we understand about cardiovascular disease and the more that we can, or the better that we can treat them, then the better that we can improve these outcomes. And so we can have a lot less deaths and a lot less financial burden as well. Okay. And so let's talk about the relationship between fluid mechanics and cardiovascular medicine. Okay. So in the last two slides, I think kind of talked about the biology of all these things, but where does engineering come into play, right? And so the first connection I want to make is between fluid mechanics, right? And so I think everyone here has taken at least some kind of fluids class. And so if you're a Cal State Fullerton student, you've probably taken 333. Maybe you took it last semester, or maybe before that. Okay. And so maybe blood flow, it was not the main application that you were thinking of when you're thinking of fluid mechanics, but there's actually a very strong correlation between fluid mechanics and cardiovascular health. Okay. Because whenever you have any kind of fluid flowing in a confined space like a blood vessel, there's a lot of forces that are caused by that flow, right? And so you have things like pressure forces, right? You have things like shear stresses, okay, that are due to viscosity, okay? And these and your blood vessels are no exception to this, okay? And the interesting thing is that a lot of these fluid mechanical forces, like pressure and shear stresses, they're actually very strongly correlated with disease, right? And so what scientists have seen is that, when you have plaque buildup like this, I think everyone's kind of seen maybe an animation like this, maybe in a Cheerios commercial or something, okay? What scientists have seen is that, when you have plaque buildup in your blood vessels, they always kind of tend to appear in kind of the same places in a human, okay? And so they don't really just appear randomly. They kind of appear in kind of in the same geometries under kind of the same conditions, right? And part of the reason for that is the fluid mechanics, right? And so a very common place for plaque to build up is a geometry like the one I've shown here. Okay, and so whenever you have a blood vessel that kind of splits off into two vessels like this, this is what's known as a bifurcation. Okay, and you don't have to write this down. We'll go over this a lot during the class. Okay, but basically, what this word means is you have a single blood vessel that splits into two. Okay, and so at these bifurcations, you have really interesting fluid mechanical flow patterns, right? So actually, let me switch my color just so it's a bit easier to see. Okay, and so in these sections, you have blood that goes this way, you have blood that goes this way. Okay, but here you have what's called an impingement point. Okay, or you've known it as something like a stagnation point, right? And so whenever you have a stagnation point in the flow, it's usually a good indicator of where disease is going to occur, right? And so that's what this image here shows, that when you have a bifurcation like this, it's a good place for plaque to build up. And in fact, you have a significant amount of plaque buildup right here, which is right at the bifurcation point. Okay. And so, if we have a strong understanding of fluid dynamics or fluid mechanics, this can lead to better understandings of cardiovascular disease. Okay. And that's kind of where this whole that's kind of where the motivation for this class comes from, is that if we can analyze, if we can simulate, if we can study the fluid mechanics of blood flow, then this should lead to a lot of really important conclusions and a lot of really important information about how cardiovascular disease is happening in humans. Okay. The difficult part is that blood flow, compared to a lot of other fluid flows that you might experience as an engineer, blood flow is extremely difficult to measure. Okay. And so it's not as simple as, I think, probably if you've taken a fluid mechanics lab, you can't just, open up someone and say, let me look at your blood flow, right? Because the blood is inside the person. And sticking probes inside people, usually people don't enjoy that either. And so, the main difficulty that we face here as engineers is that it's a system that's very hard to collect data on. It's a system that's very hard to observe. Okay. Okay. And so how do we get around that, right? And so the way that we get around that is through computational engineering. Okay. And so, if you look at kind of other fields of engineering, whenever you have a system where measurements or physical tests are difficult to do or they're expensive to perform, a lot of times simulations can be there to fill the gap. Okay. And so as an example right here, I've given you an example from aerospace. Okay. And so, from the simulation right here, you might have seen a simulation like this before, but what this is they're basically simulating the airflow that's going over this airplane wing. Okay. And so this gray kind of blob here in the middle here, this is an airfoil. Okay. And what this engineer was doing was, he used computers to simulate how the air was going to flow over this airfoil. Okay. And these kinds of simulations are utilized a lot in aerospace because it's freaking expensive to build an airplane, right? You're talking like millions and millions of dollars. And so, it's very difficult to build an airplane just for the sake of testing a prototype, right? And so what you'll see a lot nowadays, and you'll see this if you go work for an aerospace company, is that a lot of the work is actually done computationally first. And so it's done with computers, it's done with simulations, just to cut down on the cost of doing physical tests, right? And this is really beneficial because, computers can perform calculations that are way, way faster than humans, right? And so if you asked a human to perform these kind of calculations, they'd be at it for literally years. But a computer can do it, sometimes in a matter of minutes, but sometimes in a matter of hours as well. Okay. And we're at a very interesting point, in history right now too, because computers are getting, a lot stronger, and we're getting better and better at utilizing them. And so what we're seeing is a trend that computers and computations are becoming a much bigger part of engineering, than in the past. Okay. Of course, not everyone uses computers for useful stuff. A lot of people use it to do things like mine Bitcoin, but there's a lot of really cool engineering applications for computers as well, and and we're seeing that evolve every day. Okay, and so particular, for this class, we're going to be using a very specific kind of field of computational engineering called computational fluid dynamics. Okay, and so you might have heard people mention the acronym CFD before, right? And so that's what CFD stands for. Okay, and so CFD is kind of a subfield within computational engineering that refers to the computational simulation of a fluid flow. Okay, and so any kind of fluid you can simulate with CFD. So whether it be air, whether it be water, in our case it's going to be blood. Okay. And so CFD is basically the premier way that we can use to simulate it. Okay, and so the way that that's usually done is first we use a process called meshing to break up the domain. Okay, then we take our governing equation, which in this case is the Navier-Stokes equations, and solve it on that mesh, and then we display our result as a color contour map of velocities and pressures. Okay. And we'll go through this much more in detail later in the semester, but here's kind of a cool application of CFD that that I found on the internet, where they basically simulated the airflow over the sports car, and they use that to assess, the performance of that sports car, okay, relative to like, the amount of drag that it experiences. Okay. So CFD is and of course I'm extremely biased, but CFD I think is really, really cool, because I think the science behind it is really, really fascinating. It's really difficult, but it's really fascinating, and I think the results and the figures and the animations that you get from it are just super, super cool. And we're going to be using that to perform blood flow simulations in this class. Okay. Any questions on any of this so far? Okay. All right. And so, now that we've kind of talked about, kind of a little bit of the biology, so, what the cardiovascular system is, and a little bit of, what computational engineering is, let's talk about the engineer's role in biomedicine, because I think, I think a lot of people don't necessarily make that connection, all the time, because I think, medicine is performed by doctors and engineering is performed by engineers. Okay. But I think the cool news is that, engineers are playing a much bigger and bigger role in medicine every single day. Okay. And as a field, bioengineering is growing extremely rapidly, right? I know we don't have a bioengineering department here, but you're seeing bioengineering departments pop up at a lot of schools. And you're seeing those departments get more and more funding and grow and with the amount of students and faculty. So it's a really, really exciting field. Okay. And just as a very simple application, the design of medical devices is performed by engineers. Okay. And manufacturing of medical parts has to be performed by engineers as well. Okay. And so, for both of these tasks, engineering expertise is very much in demand. Okay. But also, another area where engineering expertise can be utilized is in modeling and analysis. Okay. And so an example of this is, that's very relevant to today. And I actually saw quite a bit of work on this at the beginning of the pandemic is, we can use engineering tools to analyze and model about, say how particles travel after a cough, and these kinds of simulations were used to help shape COVID safety protocols. Okay. Okay, and so before we kind of get any further, let me talk about a few kind of applications of what you can use this class for, right? And so I think the number one case study for this class, or number one application, is in cardiovascular disease research. Okay. And so we've kind of already talked about this before, right? And so even though we know that fluid mechanics plays a big role in cardiovascular disease, it's really difficult to get accurate measurements. Okay. Because you can't just look at a person and tell what their blood flow is like, and you can't stick a probe into someone. I mean, you can, but they probably won't like it, and they'll probably punch you. But that's for a different thing. Okay. But we can use simulations to basically quantify pressures and velocities, without having to do a lot of invasive measurements. Okay, and that's kind of what this class is about. Okay, and then based on those simulation results, we can identify what are some certain risk factors for certain diseases, and what are some geometries that put people at risk. Okay. All right, so another exciting application of this class would be in medical device design, right? And so this one we've kind of already talked about as well, right? And so just like any kind of engineering device, we can use simulations to help us in the prototyping and the design, right? And so here, what I've shown you here is a simulation of a blood valve, right? So this is from a colleague of mine. She actually works for the FDA right now, and she designed these valves that go inside your heart, basically. Or this is the valve that connects your heart to your lungs. Okay, and she did a lot of work in designing these valves and and quantifying how well they perform. Okay. And so the nice thing about having a computer platform for this is that you can make design modifications really easily, and you can quickly evaluate how those design modifications are going to affect performance, right? And so think about your previous classes with SolidWorks, and if you've taken a finite element class, think of those as well, right? And so in SolidWorks, if you wanted to make a modification to your design, it's as simple as just making a few clicks and hitting a few buttons, right? So you don't have to change a prototype at all. Right. And if you've taken finite elements, then you can take that design and run a simulation on it to see how well that design is going to perform. And so it's the exact same way in this class as well, right? And so you can take a medical device, you can make a modification on it, then you can run a simulation to see how well it's going to perform. And this is great because this, especially for medical devices, because this avoids you having to do any kinds of human trials, right? Which has obvious, safety benefits. Because, I think in general, everyone's really excited for new treatments and new medical devices. But I would say that no one is volunteering to be the first to try these out, right? And so, you never want to be the guy that says, hey, we have this new treatment, but you're going to be the first to test it. And so we think it might work, but it probably, but it has a risk of not working, and you don't want to be that guy. And so, that's kind of why we have simulations for these things.
Quick question, Dr. Chen.
Yeah.
So all those devices, I imagine it's pretty tiny and the tolerances are pretty tight. Do you know what kind of machine they use to manufacture that? That's accuracy.
Yeah, it's a great question. Yeah, you're absolutely right. So, all these devices are actually, really, really small. And actually, a lot of the images that I show you here in the class, I think don't really do it justice, because, this makes it kind of seem like it's pretty big. But if you think about it, the diameter for this vessel here, is probably only on the order of like 1 centimeter or something like that. So this is, extremely tiny. And so, these have to be, all these devices have to be, manufactured and designed, with a lot of precision. In terms of what techniques they actually use, that I'm actually not sure. I'm definitely a lot more on the computational side than I am on the manufacturing side. But I imagine that it's a very expensive and very precise process, because you are talking about very small tolerances, and a lot less room for error too. Because if one of these devices don't function well, and they're inside a human, then that human could be in a lot of danger as well. So, the manufacturing and risk of these devices is a big concern for sure. All right, and so one more application that we have that you can do that I've had colleagues work on as well is actually virtual surgery, right? And so this is a really exciting application, because we can use these simulations to actually perform surgery on a person, before they actually even, do it. And so this is really nice because, again, whenever you have kind of a new surgical procedure, then, you want to test it out in a simulation before you try it on a person, right? But even besides that, a lot of times when people come into the hospital and they have, a severe disease, you'd be surprised that there's not like a playbook that doctors are following to say that, if this patient has this disease, then we have to use this surgery, right? A lot of surgery is actually up to kind of the preference and the kind of the opinion of the doctors themselves, right? And so there's usually, whenever for most cases, there's usually at least 2 or 3 different procedures or 2 or 3 different approaches that the surgeon can take, to fix this person. And the way that the way that surgeons decide is that they just kind of use what they're trained to do and what their expertise is in. And so it's actually not as systematic of a process as you might think, which kind of alarmed me a little bit when I first heard that. But simulations can come in and kind of fill this gap as well. And so if you have a patient coming in and the patient needs surgery, then the doctor can say, I'm thinking of maybe 1 or 2 of these different surgeries. Can you test them out in a simulation before I actually do it? And so we can use simulations to try them out and see, how well that they're actually going to perform on the patient. Okay. I was shocked actually. So I met a surgeon, a fairly famous one at Stanford once, and he's famous for coming up with a very influential surgery that that a lot of people use. And I just asked him, how'd you come up with the surgery? It must have been you must have followed a very rigorous process of, and you drew upon your past expertise, and it was peer-reviewed and everything like that. And, it must have been a very long process. And he said, actually, he was working as a young surgeon, and a patient came in and he had an issue, and, and he had never seen that before, and nobody had ever seen that before. And so he just tried something. He said, the patient's dying in front of me and I have to do something. And so he just tried something, and it happened to work. And now he's famous for it. So that was very surprising to hear. But, and thankfully it worked out for that patient, and, thankfully it worked out for that surgery. But, now that simulations are becoming a bigger thing, we can probably do it better than that. Okay, and so I spent a lot of time talking, and so I know probably a lot of you are coming in with different interests in this class, and so I want to turn to you guys, and so what are some examples, what are some applications, or what are some things that you're interested in learning from this class? And so you can just go ahead and shout it out. And so if you want to turn on your mic, you can go ahead and do that, or you can put it in the chat, and I'd be happy to read that as well.
For me personally, like blood clots, cholesterol, problems that don't exactly form directly in the heart, but problems that form in the bloodstream that are very hard to detect is something I'm rather curious about.
Oh yeah, no, that's a great great example there. Yeah, blood clotting and cholesterol and plaque formation, I think, is of interest to almost everyone, especially in America, because of the diets we kind of we kind of eat here. So yeah, we will definitely be discussing that a lot. Yeah. Mm-hmm.
Interested in learning about blood pressure also, because personally I have high blood pressure myself, so I am not allowed to be angry to a point that I need to hold my neck.
I see. Yeah, but yeah, blood pressure, really, really fascinating, and I think it's a much more complicated and a much more involved quantity than I think a lot of people give it credit for. But yeah, blood pressure is extremely important for people, and we'll be talking at length about what causes high blood pressure and the fluid mechanics that actually go into that, because actually you can explain high blood pressure from a purely mechanical point of view, and so I mean, the biology kind of leads up to it, but the reasons you have high blood pressure are purely due to the fluid mechanics. So definitely going to be a very interesting part of the course when we get there. Yeah, thanks for sharing.
I'm wondering if that part of engineering can also connect to the psychological part of it, because it's mostly because of my psychological issues that makes me have high blood pressure.
Yeah, no, I think so as well. So a big part of the fluid mechanics and of the geometry of your blood vessels, they're influenced by your hormones. And so, that's kind of where the psychological aspect comes in. And so when people, feel a certain way, like when you get stressed about something, or like when you feel excited about something, then a lot of times, your body will release hormones into your body. And that actually, I think a lot of times we talk about hormones as kind of this like, chemical thing that happens in your body. But a lot of those hormones are released, and they actually cause physical differences in how your blood vessels are shaped. And so that's probably what's going on, is that when you have those feelings and those psychological effects, it releases hormones in your body, and that actually causes the geometry of your blood vessels to change, and that causes things like high blood pressure or other issues like that. Yeah. Mm-hmm. Right, anybody else?
Yeah, I'm just interested because I'm currently interning in the dental manufacturer company. That's why I was asking the manufacturer question earlier. It's all about this field of like mechanical and human bodies, but the accuracy of whatever device we're manufacturing here is definitely more accurate than any oral surgery. So I'm just curious on that.
Yeah, no, that's great. I think I think a lot of people come in with strong interest in medical device manufacturing design. So yeah, definitely we have I have a few lectures talking about that as well, and I'll try to see if I can look up some more information about manufacturing methods, because I think it is really interesting, and it's not something I've thought too much about before. Yeah,
I would say like injections fuel, having like gas pressure, and then having like the turbines, or what's it called? How you can minimize like efficiently.
Mm-hmm. Yeah. No, it's and that's a great point, because actually the human body, I think if you look at it from an engineering point of view, it's a very well engineered system, and so your body actually has a lot of mechanisms to control things like your heart rate, or things to control like your blood pressure, to really optimize the performance of the human body. So we're definitely going to be talking a lot about that as well. Yeah. In the chat. So I'm curious about how blood flow will behave compared to water or air. Yeah, that's a great question. And so that's a question about blood rheology. And so that's a question about what the viscosity of blood is like, what the density of blood is like, and how it performs under shear. And so probably a term that you might have heard before is that blood is actually what's called a non-Newtonian fluid. And so that means it doesn't exactly have the same behavior as other fluids. And in fact, blood is actually characterized as what's called a shear thinning fluid. And so that means the more that you shear the blood, the thinner that it gets, or the less viscous that it gets. And a big reason for that is blood has to squeeze through, these very tiny capillaries, which are, literally micrometers in diameter. And so if blood were a normal fluid, it literally wouldn't be able to fit through those holes. But the fact that, the more that you shear it and the thinner it gets, it really helps the blood to squeeze through those channels, which is vital to human function. Yeah. Yeah, great examples, guys. Anything else before we move on? Okay. All right, and so I do want to have a slide on this too, because for myself, I'm mostly an academic by training. I've just gone to grad school and I've come here to teach. But there is a strong industry industry interest in science like this and in work like this, right? And so in particular, I want to highlight a company called HeartFlow, which is located in Northern California, and so it's in Redwood City. Okay. And so they actually use computations like this to perform their work. And so I actually have a really good friend that works at HeartFlow. Last year I got him to give a guest talk at the end of the course. I haven't reached out to him yet, but I'll try to get him for another guest lecture for this semester as well. Right? And even besides HeartFlow, you're seeing a lot of big biotech companies, things like Edwards Life Science, Medtronic, and Siemens, all these big name companies. Samsung, I know is getting into this space as well. That are really interested in computations of blood flow. So it's a really exciting field to be in, at this stage in history. Okay, and so that's the introduction to the course. And so it's great to hear that a lot of you have really strong interest in the course, and you're really excited to be here. Because that makes me really excited to teach this course as well, right? And so for the rest of class today, I do want to go over the syllabus, right? And so if you want to follow along, you can download the syllabus from the course website, or you can just kind of sit here and watch me read about it. And I want to go over kind of all the kind of most important information from the syllabus, as well as some important policies that we have for the course. All right, so let's talk office hours. And so office hours are going to be in my office, and so the location for my office is 5 CS 526. I'm not there right now, and I won't be there for 2 weeks because of the mandate. And so office hours will be conducted over Zoom. Okay, and the Zoom thing will continue on even beyond the 2 weeks from now. And so I'd like to have that option because it's kind of a pain to come to my office because I'm on the 5th floor, and I know a lot of you are kind of working kind of full time, and so. I think it's just kind of easier for everyone to have the Zoom available to you, but at least after the first 2 weeks, I actually will be physically in my office, and so you can come to office hours, or you can do Zoom. Either one's fine. Right? And so the times that I have for my office hours are Mondays 11 to 12. I have Tuesdays from 9 a.m. to 10 a.m. and then Thursdays from 1 p.m. to 2 p.m. Right? And so I try to vary my office hour times just to try to make it work for as many people as possible. But with that said, I know that there are those of you out there who, these times don't work at all for any of you. And so if these times don't work, or if you want to meet with me, outside of office hours, then, I'm always happy to make appointments for people, right? And so just shoot me an email, and then, we can try to find a time that works for both of us. Okay. Because I leave time in my schedule. I leave a lot of gaps in my schedule to meet with students, outside of these office hours, right? And so, just shoot me an email whenever you need to talk. And usually office hours, for this class will be a little bit unique, but for most classes, office hours for, clearing up any confusion you have on the course content. If you have questions on the homework problems, or you need clarification on some feedback on the exam, then that's what office hours are for, right? But for this class, because the project is kind of a big significant portion of this class, a lot of you that are going to come to office hours are going to be asking for help on the project, and I'm more than happy to provide that help. Okay. All right, learning objectives. And so, we talked about these at the beginning of class, but I wanted to show them to you again. Okay. And so in addition to, class by class learning objectives, I also have learning objectives that apply to the entire course overall. Okay. And so by the end of the course, you should be able to do all of these things here. Okay. So I'm not going to read them just because we're running a little bit short on time, but you can definitely read them yourself. Maybe a lot of these won't make sense yet, but I think as we go through the course, you should be able to accomplish a lot of these learning objectives. All right, deliverables. And so right now I have 6 homework assignments that are planned, 1 midterm exam, and so that's going to take place actually very near the end of course, and 1 midterm project and 1 final project. Okay. The homeworks, they're going to be graded on completion, because this is a technical elective. And so, for these kinds of courses, I don't like to grade for correctness because, I know everyone wants to be here because you chose to be in this class. And so I don't have to be as strict on grading the homeworks. And so, the homeworks will be graded for completion, and the lowest homework will be dropped. Okay. And so the reason I do that is, I know the semester gets really busy. For the seniors in the class, I know senior design is going to take over your life if it hasn't already. And for the graduate students, I know a lot of you are working full time as well. So, I'd like to give you flexibility so that you don't have to feel like you have to turn in every single homework assignment on time to get full credit. And so by dropping the lowest homework, hopefully that gives you some flexibility in how you determine your schedule. Okay. But with that said, please do them all. And so, you'll probably disagree with this statement, but I don't assign homework problems to be busy work, right? And so I assign my homework problems, very thoughtfully, to give you the practice, to really, hammer home the concepts from the lectures. Okay. Because with engineering, probably a lot of you know this, that you can't just listen to someone lecture to you about engineering and expect to grasp it. You really need to practice it on your own. And that's especially true for a class like this, where the software is going to be a big portion of it. And so you need to practice with the software. You need to practice doing the calculations, in order to really grasp it. Okay. And that's what the homeworks are for. And even on a more short-term basis, I like to make my homework problems, harder than the exams, right? And so what I tell people is that if you can do well in the homework assignments and you understand all the problems, then you're in great shape for the exams. Okay. And so I do push pretty hard on my homeworks. And so I do assign pretty tough problems that take, a bit of time and a bit of thinking to complete. But all that, I want you to feel like the time that you invest in the homework is going to be worth it, right? So not only in, of course, in learning the course content, but, in the short term as well, the time that you invest in the homeworks is, going to pay off when the exams come in. Okay. All right. And so a little bit about the midterm project. So this will make more sense kind of when we talk later, but the midterm project is basically going to be a kind of almost like a midterm check of your final project, because the final project actually has quite a few steps and quite a bit amount of work to it. And so, I'm having the midterm project be kind of at a very key checkpoint in the final project, just to make sure that you've completed that, at a certain date, before you start running simulations for the final project. Okay. Because what happened last year when I taught this class is that a lot of people kind of pushed off the final project until the very end. And then they realized that, the final project, man, this is going to take me, tons and tons of time, and they didn't really start it until the very end. And so I want to avoid that situation this semester. And so I'm going to have a pretty comprehensive check of your final project, kind of near the end. Okay. Or I should say about a month before it's due. Okay. Because you're gonna need about a month after that checkpoint to do everything else in the project as well. Okay. And so here are all the dates that I have planned for everything. Okay, so the midterm project is going to be due on Friday, April 15th. The midterm exam is going to be on Thursday, April 28th. And then the final report is going to be due on Monday, May 23rd. Okay. I do want to talk about the midterm exam a little bit. Okay. And so if you remember reading from the introduction email that I sent, you can continue to attend this class virtually for the rest of the semester. Okay, so I plan on streaming all the lectures on Zoom. And so if you want to attend virtually, you have the option to do so. The only day that I'm requiring you to come into class is going to be the day of the midterm exam. Okay. And so, please plan on coming to campus by that day. And of course, if COVID, if we have a new variant or something and we're all forced to stay home, then, I'll make the adjustments at that time. but at this time, the plan is for to have the midterm exam in person, right? And the reason I'm doing that is just to kind of help keep the exam fair, kind of for everyone, because if you come in to do the exam, it's kind of an even playing field for for everyone. All right. Any questions on this so far?
I have a question.
Sure.
You said you were gonna stream and be in present like in class, right?
Yep.
When you stream, is it gonna be recorded?
Yes. Yeah. So all the lectures are going to be streamed. They're all going to be recorded. And so after 2 weeks, I'll start going physically to the classroom. I mean, assuming that the mandate is lifted. But from the classroom, I'll basically be using my iPad to write notes, and I'll be recording it and posting it on YouTube. Yes.
Okay. Thank you.
Yep. All right. So course grades, and so here's how the grades for the course are going to be broken down. And so the homework is going to be worth 10%. The midterm project is going to be worth 20%. The midterm exam is also 20%, and the final project is going to be worth 50%. Okay. And then based on the, based on your final score in the class, I'm going to assign letter grades, based on this scale. So I think this is all pretty standard. Okay. All right. Oh, question. For homework, is it included programming or simulated project? For the solution, are you going to record it or show the solution? Yeah. So for the homeworks, most of it is going to be hand calculations, or a lot of it's going to be conceptual questions as well. And so a lot of the homeworks are going to involve like short answer questions, or solving for a problem on paper. There's going to be a little bit of MATLAB programming in the homeworks. I'm gonna try to tailor it back this semester, because last semester it was kind of a little bit difficult to do. But I do plan on posting solutions for all the homeworks after they're due. And so after they're due and after everyone turns it in, I like to post the solutions just so you can use them for your reference. Yeah. Okay, and so here's how the course grades are going to be broken down. And so you can see that the final project is a very big portion of the of your grade. And so I know that's concerning to a lot of people, and I will say that I promise to provide all the support that I can for the final project. Okay. And so the only thing I can say is that I'm going to give you pretty advanced notice on the final project, and in fact we're going to start it in about a month. And so the project is going to go basically for the last 10 weeks of the semester. And so definitely plan on working on the final project throughout this semester, right? And throughout that entire time, I promise to support you as much as I can to help you succeed in that project. Okay. All right, textbooks. And so the primary source for this course is going to be a course reader, and that's provided to you. And so the link for that is going to be on the course website, and I'll show you that link after this portion of the slides. Okay. And then the other textbook that I'm going to be referring to is this one right here, which is a book by Hoskins on cardiovascular biomechanics. Okay. And so this book is not required by any means. And so, I plan on posting all my lecture notes. And so you won't need to use this as a reference. But if you do plan on picking it up and you are interested in reading more, this is the textbook that I'm using for the course. Yeah. Question. So how's the midterm project? So the midterm project is actually kind of a checkpoint for the final project. And so it's kind of a check of your progress on the final project up to that point. And so, like I mentioned, the final project, we're actually going to start it, in about a month. And so, the midterm project will be due about a month and a half after that. And so the midterm project will be kind of a pretty significant check on that part of the final project. Yeah. And so it's all kind of part of one thing. Yeah.
Professor?
A question?
Just to clarify, so like the project, it's safe to say that it's 70% of the grade, right?
Correct.
Since it's 20 and 50. Okay, making sure.
Correct.
Thank
Correct. You. Yes. Yep. All right. So for the textbook, if you do plan on picking this up, try to find a cheap one. I always paying full price for a textbook because I think the textbook industry is run by the mafia. And so, if you do plan on picking one up, try to find a cheap one. You don't have to find this version. Actually, I think there's only one version. But hopefully you can find a cheap one. And I always tell people that, if you just so happen to find a free one that's kind of floating out there on the high seas, then, I think that's a good option as well. Okay. All right, software. And so, like I mentioned before, we'll be using MATLAB in this course. Not as heavily as I did last year, but we will be using MATLAB a bit. Okay, and so please make sure that you have MATLAB on your computers. And so if you don't have a version of MATLAB, you can download the student version, and you can download that through Cal State Fullerton. Okay, I think if you just Google MATLAB Cal State Fullerton, then there are pretty clear instructions how you can download that. Okay. And in addition to MATLAB, the main software that we're going to be using is a software called Syllabus. Okay, and so this is very much a research software, and so this is not a standard software that's used out there in industry, but it's the software that we're going to be using to build our geometric models and to run our computational simulations. Okay, and so we'll be using Syllabus actually quite a bit this semester. Okay, and so this is what your final project is going to be in, is in using this software. Okay. And so, I think the next slide is the final project. Yeah, okay. And so the final project, and the midterm project will consist of basically constructing a patient-specific geometry of a person's blood vessels and then running a CFD simulation on it. Okay, so let me give you an image of what that looks like. Okay. And so this is an image of, actually, this is a model that I've run. Okay. And so you can see here what I've done is I've created basically a CAD model or a computer model of this person's blood vessels. And so if you're wondering where these blood vessels are located, this is actually right outside your heart. And so your heart is actually right here. Okay. I know a heart's not shaped like that, but just for illustration purposes. Okay. And so this is this is what's called your aorta. Okay. And we'll go over kind of basic anatomy and names and stuff in the next class. Okay. And so basically what I've done here is I've run a simulation where the heart is ejecting blood out the aorta, okay, and into these side vessels called coronary arteries, okay. And then what I've done is I've basically quantified the blood pressure inside this model, okay, using purely computational methods, right? And so you're going to be doing basically, about the same. And so you're not going to get the same model as this one, but you're going to be getting very similar looking models as well, okay. And so, we'll be talking a lot more about the final project kind of later on, but this is kind of what you're going to expect. Okay. And so you're going to build, and so again, you're going to build a geometric model or a CAD model of a person's blood vessels, and that's going to be based on their medical image data, right? And so you're going to get a CT scan of a real person, and you're going to construct the geometry of that person, and then you're going to run a computational simulation that of that person's blood flow. Okay. Any questions on the project?
Yeah, quick question. So I think earlier you mentioned that every person's blood vessels are similar, or they're the same.
They have the same overall structure, but the exact shape is a little bit different. And so think about just kind of everyone kind of in general, right? So every human, or most humans, kind of have the same general structure. So we all have 2 arms, 2 legs, a head, and chest and things like that. But the exact shape and the exact geometry is a little bit different. And so it's the same for blood vessels. So everyone kind of has the same major blood vessels in terms of names, but the exact shape and size is different for everyone. Yeah.
Okay. And that's what you mean by patient specific?
Exactly. Right.
Okay.
Yeah. Mm-hmm.
Okay. Thank you.
Yep. Mm-hmm. All right. Course website. And so, I'll give a tour of the course website after these slides, but I do want to kind of give a brief overview. Okay. And so the course website is going to be basically your main point of contact for this course. Okay. And so any content that I produce for the course, whether it be like lecture notes, homework assignments, solutions, study guides, tutorial videos, for this class, there's going to be a lot of kind of software instructions as well. All of that's going to be posted on Canvas. Okay. And so I update the Canvas, pretty regularly. So, you should definitely keep up to date on the Canvas site, to get the most up-to-date information and files. Okay. I'm also going to make announcements through Canvas. Okay, and so you've probably all seen that already. And so I've mentioned announcements and it emailed all of you. Okay. And I've also made a Discord server for this class as well, right? And so I think a lot of you have noticed that already and have joined. And so thank you for that. But the Discord, I love the Discord because it's kind of a really nice informal place for all the students in the course to kind of interact with each other. Okay. Because of COVID and all the virtual instruction, it's been hard to have kind of a physical classroom where everyone can meet. And so the Discord kind of is a substitute for that, right? And so on the Discord server, you can basically interact with your classmates. And so I've seen people ask questions on the homeworks on Discord. I've seen people share memes on the Discord. I've seen people organize study groups. I've seen people make fun of me on the Discord, and so it's great, and I think it's a really kind of informal place, kind of low stakes place to kind of interact with people, which is normally really hard to do in a virtual environment, right? And so and so if you haven't done so already, I encourage you, please join the Discord server and introduce yourself. And so you'll see on the Discord server I have a channel for introductions, and so please introduce yourself and just start chatting there, right? I will say that I am teaching 4 courses this semester, so I'm not going to be that active on the Discord server. And so I've basically just created it as a place for you to interact with your classmates. Okay. But with that said, if you do want my attention, you can summon me. And so if you tag me on the Discord server, I will come in and answer a question. Okay. Another policy I have is that if you I do let students kind of direct message me on Discord, and usually that's a quick way to get a hold of me. But I do ask that that you please save that for emergencies. Okay? One semester, actually the last time I taught this class, there would be times where I would wake up and I would have like 20-25 messages, direct messages from students on Discord, and it kind of got a little bit out of hand, especially because I use this Discord for my personal use as well. And so you can message me on Discord, especially if it's kind of an emergency situation, but please only save it for emergencies. And so if it's something that doesn't need my immediate, instantaneous response, I would ask that you email me instead. Okay. All right, course policies. And so here are some additional policies that I have for this course. Okay. And so the first is with regards to late homework. And so I do accept late homeworks in this class. And so, but each day that it's late, it's docked 10%. Okay. And so if you can't meet a homework deadline, please, please do still submit it. And so I can, for a lot of times, I can still give you most of the points. But I do have to dock points because it is after the deadline. Okay. Regrades. I'm human just like everyone else, and so I make mistakes. I don't try to, but I do make mistakes in grading homeworks and exams. And so if you want me to take a look at something again and you feel like I've made a mistake, then please let me know. I'm always happy to look at it. Okay. But you can only do this for a week after I've returned it to you. And so don't come to me in the last week of class and ask me to regrade your homework 1, because that's that was like months ago. So okay. And emails, and again, I'm teaching a lot of different courses this semester, and so if you can help me out just by organizing my email, it would do me a big favor. And so if you're contacting me about this class, please include the course number in the title. And so if you can put EGME 442, if you can put it in square brackets, that would be great too. And any subject and the subject line for any email, that would help me out a lot. And I usually am really prompt in answering email, so I'll try to answer you same day, but if not, next day, and worst case 48 hours, with the exception being on weekends, because on weekends a lot of times I go out and I don't have access to my email, and so that's the only exception to that. Okay. All right, so academic dishonesty, and so this is kind of my least favorite portion of the class. And I will say for a class like this, which is very niche, it's usually less of concern, but it is something that we have to talk about, right? And so academic dishonesty is not going to be tolerated in this course. And so if you commit any form of academic dishonesty, and so that includes copying solutions off someone, or posting questions online and copying questions from there, or for the final project, copying someone's report or copying someone's project, at the very least, it's going to result in a 0 on that assignment. But if it occurs on something serious, like on an exam or on the project, most of those I just give an automatic F for the course. Okay. And so I know it's a hard line stance, and I know I'm very tough on academic dishonesty, but the reason I have to do this, or the reason I do this, is to because I want everyone to learn from this course. Okay, so the objective, the objective that I want for everyone is not to just pass the course, but I want you to take away knowledge and take away skills, right? Especially for a course like this, which is so kind of unique and so niche compared to other compared to the rest of our department. I want you to come away from this class, with a lot of really cool knowledge, with a lot of really cool skills. And so, if you commit academic dishonesty, end of the day, that it just takes away from that learning. Okay? I have a little cousin, and so he's not so little anymore. And actually, he's much bigger than me. He plays catcher for his college, for his college baseball team. He just finished his first semester in college, and he asked me, he's like, "Man, Justin, why are professors such hard asses on cheating? It's like, don't you have better things to do than to catch cheaters?" And I'm like, I do have better things to do, but all we want is we want you to learn. All your professors want is we want you to learn. Okay. And by cheating, you kind of take away from that. And I hate to think of my job here as police, but sometimes I kind of have to be on these things, right? And so it's a hard line stance, but but with that said, whenever I have kind of a hardline policy like this, I want to give something back in return. And so, my kind of offer to you is that if you ever feel like that you're struggling in this course, or you ever feel like you're falling behind, or you feel like you're not going to do well, especially on the project, because on the project in this course, it's easy to kind of to have that thing get out of hand. Please reach out to me before you consider doing academic dishonesty. Okay. And if you do that, then I promise you that I'm not going to judge you. I'm not going to criticize you. I'm not going to berate you or lecture you or anything like that. I promise you that I'm going to do everything I can to support you and to help you succeed. Okay. Because if everyone succeeds, then that's a success in my book for this class. Okay. I've had students that came to me, literally like, less than a day before the exam, and they say, yeah, hey, professor, I've missed the last 5 lectures or last 5 weeks of lectures. I haven't done any of the homeworks, and I'm really scared about this exam. Can you help me out? And I said, all right, we have 16 hours until the exam. Let's come up with a game plan to get you caught up, on the material so that you can do well. Okay. No judgment, no anything. Okay. And so I promise you, I promise you I'll help you out, but you have to come to me for that. You have to come to me for that. And so if you come to me, then, we can always work something out. We can always, rectify the situation. But if you commit academic dishonesty, honestly, there's nothing I can do, because we have policies in our department. I have policies in this class, and I have to carry through on those policies, right? But if you come to me before then I promise you I'll do everything I can to help you. So please just give me that chance. That's the only thing I asked. Okay. All right, and so with that, the slides are almost done, and so I do want to remind you of the first assignment that we have, which are the email introductions. Okay. And so your first assignment is just simply send me an email, and I'll give you full credit for completing it. Okay. And so, what I always like to do is I always like to get to know my classes. And so I'd like to get to know the students, what they're interested in, what their goals are, what they want to learn from the course, because that helps me, right? And so, not only, does it help me, get to know you guys, but, it helps me design the course to, be as useful to everyone as possible, right? And so if you can send me your email, before this Sunday, January 30th, then you can get full credit for it. Okay. And don't forget to put EGME 442 in the subject line for that email. Okay. All right. Any questions on the syllabus? Okay. All right. And so for the last 8 minutes of the class, I do want to go over the course website. Okay. Now that I fixed the typos on the course time. Okay. All right, and so if you go to the course website, this is the page that you're going to be greeted with. And so this is the home page. And so you can see here, we have the title of the course, right? We have a little bit of a description here, and we have the learning objectives, right? Here's my name, right? And so if you click on my name, you can see, a link to my page, right? And so it's kind of like my Tinder profile for teaching. so I hate reading that because it always embarrasses me, but you can read that if you want, okay? And so if you look at the rest of the homepage, you can see here is the syllabus, and so you can download that, and you can see all the information that we just covered. Here's the course reader, and so the course reader is given to you for free, okay? And so please download the course reader because a lot of the information in the course is going to be taken from here, okay? So make sure you download that and refer to it throughout the semester, right? Here are all the Zoom links with the type was fixed, right? And so you have the lecture Zoom link, which all of you are part of right now. And we have the Zoom links for all the office hours as well. Okay. You know, since this is the second time I've taught this course, and last time I taught this course was completely virtual as well. And so you can find a link to all the YouTube recordings here. And if you want to join the Discord server, you can do so from this link here as well. Okay. Any questions on this part of the course website? Okay. All right, and so the next thing I want to bring your attention to is the course outline, okay? And so this is kind of the main part of the homepage that I want you to remember, okay? And so you can see here from the outline, I've broken up the course into each of the 16 weeks, and each of those weeks I talk about or I mention, you know, what the topics are we're going to go over for each of those weeks, okay? And so as we go along in the semester, each of these links are going to become clickable. And then once you click on those links, then you'll be able to view what I call the weekly page for that week. Okay. And so the only page I have active right now is week 1. Okay. And so if you click on the link for week 1, you can see here that you have the title. I have a little bit of a description. So I have a blurb that describes, you know, what we're going to go over that week. I have the learning objectives for the week as well. Right. Here I'm going to have the links for the recorded lectures, and so you know, because I'm going to be giving all the lectures on Zoom, you know, I'm going to be posting those recordings on YouTube, and so you can go ahead and click on these links, and you can view the lectures, you know, from there, right? Here I have a link to all the assignments that are due, and so, you know, for now we just have one assignment, which is just the introductions. Okay, so you can go ahead and click on that. And then down here we have the files, and so all the lecture notes and all of the lecture slides, you know, for that week can be found from these links down here. Okay. And so far, you know, we've covered the first set of lecture slides here, which is the all the introduction stuff. And then on Thursday, we're going to be going over this lecture notes, which is on basic anatomy and physiology. Okay. Right. Question. Question. So for the midterm, is it closed book and notes? Yes. So it's going to be closed book, closed notes. But I do allow students to bring a 1 8.5 by 11 cheat sheet for the exam. Yeah, and so you can use both sides of the sheet of paper, and you can write anything that you want, and you can bring that to the exam to help you out. Yeah. And so I've seen a lot of people use the cheat sheet for different things, and so what I recommend is that you kind of write the cheat sheet from scratch. Because, you know, the act of, you know, summarizing and condensing the information from the lecture notes onto the cheat sheet, I think is by itself a really great study tool. But what I've also seen people do is that they've taken all my lecture notes, they've taken all the homework solutions, they make it really, really tiny and just put it on the cheat sheet and just print all of it out like that. And so you can do that as well. You know, I'm not stopping you from doing that, but, you know, I wouldn't recommend it because it's a little bit too much information to be looking through on the exam. Midterm will be like math problem. There will be some calculations that you'll have to do on the midterm. Yes, if that's what you're asking. Yeah. Mm-hmm. All right. All right. And so that's the home page, and that's the weekly pages. Okay, so definitely check those out. And so I like to update the weekly pages, you know, on the Fridays before the week. Okay. And so by Friday of this week, you should be able to click on week 2. And that's, you know, and I do that just so that, you know, if you want to read ahead and see what's coming up for that week, you can do so. Okay. All right. And so the next tab that we'll look at is the assignments tab. And so this is basically a tab that has all of the assignments. Okay. And so right now you just have one, but, you know, all the homework assignments, all the project stuff will be, you can find that information here. Okay. All right. And so the next tab is for grades. Okay. And so, you know, if you once I've graded stuff and once you've turned some stuff in, then you can check your grades here. Okay. And so this will be your most up-to-date source for what your grade is at the current time. You can click on people, and so this will have a list of all your classmates. Okay. And the last thing I want to show you is the files tab. And so this is basically where I'm going to store all the files for the course. Okay. And so you can see here, I've broken it up into several different folders. And so I have a folder for assignments. Here's the course reader here. Here's the syllabus. I have another folder for code. And so any kind of example code that I show you in the class, or any kind of starter code that I'm giving you for the homework, I'll post that here. Okay. But you'll find links for this, throughout the weekly pages as well. Okay. And you can also look at the folder for lecture notes. Okay? And so I've actually posted all the lecture notes that I plan on using for this semester. And so you can just kind of bulk download all of these files onto your computer, and you can start looking at the notes. Okay. And any solutions that I post, whether it be for the homework assignments or for any kind of activities or any kind of exam solutions, will go into this folder as well. Okay. And so if you need to find a file very quickly, then this is basically the place that you can do it. Okay. All right, and so that does it for the tour of the website. Are there any final questions before we wrap it up for today? All right, and so that's all I had planned for today. And so again, thank you everyone for tuning in for the first class. And so on Thursday, we're going to be back here on Zoom, and we're going to start talking about basic anatomy, cardiovascular anatomy and physiology. Right. So thank you everyone for tuning in. Hope everyone enjoys the rest of their evening. And I will see everyone on Thursday.
Thank you, Professor. Have a great night.
Thanks, Hudden. See you too.
Thank you, Dr. Schreight.
Thanks, guys.
Bye.
Thank you,
Take care.
Professor.
Thanks, guys.
Quick question.
Sure.
I have you for another class, and you have the same assignment for the email.
Yep.
Would you want a separate email for each class, or
you can just send one, but in the subject line, make sure you mention both classes so I can give you credit for both.
Okay, thank you.
Yep.
Hey, Professor, I have a question for you.
Sure. What's up?
So for the sake of like having the program that you were talking about when we run it, is it as like in computer intensive as like ANSYS or something? Would we have to try to like? Go ahead.
Yes. So you'll download that on your computer. The actual simulation part is actually more intensive than ANSYS, but you're not going to be running that part on your computer. And so I've arranged for you to run the simulations on a supercomputer.
Oh, okay, awesome.
Yeah.
I was going to say, like, I don't know how we would be able to run it like at home versus on.
Right.
Like, yeah.
So there will be parts that you need to run at home. And that's basically the CAD part of the software. And so if your computer can run SolidWorks, it can definitely run this because it's lighter than SolidWorks on the CAD front.
Okay, cool. All right, that sounds easy enough then. I was just concerned about like the intensity of that because I know like last semester with ANSYS we had the virtual computer lab to work with.
Yeah, it's different than the virtual computing lab. I think it works a little bit better than the virtual computing lab. So it's
okay, cool.
It'll be nice.
Okay, and is this class going to be kind of like similar where we get to do activities where we like learn about it rather than just kind of like watching you do it?
I do have a couple workshops in the class planned, but they're not going to be like the activities from last semester because there's this software is a lot more niche than ANSYS, and so it doesn't have as many features. And so I only have about 2 workshops that are planned, and those will be interactive, and so you can definitely follow along with them.
Okay, awesome. Thank you.
Did you guys have any other questions?